We will start by showing how to do a structured calculation in the EMAT Studio environment. As an example, we'll look at this very simple expression 2 times parentheses 3 plus 4 minus 3 times 4. And we will do this calculation as a structured calculation. The first thing we do is that we add a calculation element. So if you notice here below this text here, there is a weak gray line. If you move the cursor there, it shows the possible elements that you can insert here after the text. So there is first a text element, there's an image element, then there is a calculation element. If you click here on the plus, there will be lots of other kinds of elements, which we will maybe come back to later. But for the moment, we will be happy to just insert a calculation element like this. Here first is a title. We can write here a title for our calculation. It's not part of the calculation itself. And then the next thing we want to do is we want to start calculating the value of this expression. So we copy the expression there and we paste it here. And then by hitting return, we will get a equality sign here automatically, and then we get the copy of the first expression. We are now going to modify this first expression as part of the calculation. And next to the equality sign is a place where we explain what we are doing. In this case, we write here that we add the parentheses numbers like this. So that explains what is going to happen in this step. So when we actually do this, we find out that 3 plus 4 is 7, like that. Hitting once more gives us a copy of this one, the next step, and the next step we do the multiplications. So 2 times 7 is 14, and 3 times 4 is 12, like this. And then one more, and we do the subtraction, and we find out that this is 2. So the idea here is that each step is written with an explanation on its own line, and the explanations are there because it makes it much easier for the teacher to understand how the student is thinking, and for the student to see what he was thinking when he is trying to understand and maybe find out errors in his own calculations. Let us now summarize the structured derivation notation. Each expression is written on a line of its own, like this. And the relationship between each expression, here equality, is written between the expressions, like this. And next to the relationship, we have an explanation or a justification for this step. Why is this step correct? We can compare this notation to standard mathematical calculation, the way it's usually written. And we can see that it has exactly the same steps. Here are the expressions, same as in the structured derivation, like here. Here are the relations between them. And often one writes the explanations or justifications for the step next to this. Here. The disadvantage of writing it in this way is that now expressions and justifications are sharing the same line. It becomes more compact, but it gives less space for both expressions and justifications. The structured derivation notation gives more space for each expression, the whole line, as well as the more space for the justification. And by doing it, it emphasizes the importance of explaining each step in the calculation. In particular, in mathematics education, it's important that the students understand that a calculation step always has to have a justification. There must be some rule or argument that says that this step is correct. The structured calculations were originally introduced as the calculation of style derivations by three computer science researchers, Edsger Dijkstra, Wim Feyen, and Nettie van Gasteren in the 1980s. Their main motivation was to show more clearly the argumentation that justifies a calculation. Our presentation here and the course will focus on structured derivation, or the structured derivation style, which is in fact an extension of the calculation style to more general mathematical derivations.